We are back at lesson 2.3. This is part 2. We don't have many examples left. The other video was getting kind of long, so I decided to break it up into 2 parts. So let's go ahead and look at example 4. This is a problem-solving application, in other words, a word problem, and we want to be able to find the key words. The key words are going to help us to understand the problem. So a problem is broken up into 4 pieces, or the problem-solving process. Number 1 is to understand the problem. Number 2, we have to make a plan. Number 3 is to solve the equation. And then 4 is to look back and to see if our answer is reasonable. And so if we can't get to number 1 to understand the problem, there's no hope in getting to the other 3 parts. And yet, understanding the problem can be learned. It's not necessarily going to happen overnight, and this is why so many people have difficulty with word problems, because they don't understand that they have to drill deep into the problem and first understand it. Once that happens, steps 2, 3, and 4 will progress a lot easier. So let's read through the problem first, and let's understand it as best as we can. Alex belongs to a music club. In this club, students can buy a student discount card for $19.95. This card allows them to buy CDs for $3.95 each. Notice I've highlighted that word. After 1 year, Alex has spent $63.40. Write and solve an equation to find how many CDs Alex bought during the year. Okay, let's go back and simply read the first sentence. Alex belongs to a music club. Well, good. But that doesn't tell me anything mathematically. That sentence is just the setup to the problem. It's to give the problem context, to give it some kind of situational meaning. But it doesn't tell me anything mathematically. So there's nothing in that sentence that's going to help me set up the equation. Let's go to the next sentence. In this club, students can buy a student discount card for $19.95. Now that does tell me something mathematically. There's a discount card that needs to be purchased, and the cost for this card is $19.95. I don't have to buy multiple cards. I only have to buy 1 card, and I can get discounts for every purchase after that. So that's the value that the second sentence has. All right, let's look at the third sentence. This card allows them to buy CDs for $3.95 each. There's that word each if you go back to the Dory problem at the beginning of the lesson, the previous lesson. So since CDs are $3.95 each, $3.95 is a rate. It's a multiplier. So whatever our variable is, we're going to multiply it by $3.95. Whereas the discount card, $19.95, we only have to buy 1 of those. So in other words, $19.95 is only going to appear 1 time in the equation. Let's read the next sentence. After 1 year, Alex has spent $63.40. Now that number is a total. Alex has spent a total of $63.40. So in other words, we're going to have some kind of equation equal to $63.40. Let's read the last sentence. Write and solve an equation to find how many CDs Alex bought during the year. We're asked to do 2 specific things. The first thing we're asked to do is to write. So in other words, we need an equation on paper. The second thing we're being asked to do is to solve. And the question comes when we see the word how, or how many. So that's what we're solving for. How many what? How many CDs Alex bought during the year. And that tells us what our variable is going to be. So, can we understand the problem? The answer that we're going to get will be the number of CDs that Alex bought during the year. I always tell my students to try and find the how, the what, the when, the where, and the why. and that usually helps us figure out what's being asked of us. So let's list all the important information. Alex paid a one-time fee of $19.95 for the student discount card. Alex also pays $3.95 for each CD, so this is a rate. And after 1 year, Alex has spent $63.40, so this is a total. Now I can kind of make a plan based upon the information that I know. I'm going to let C represent the number of CDs that Alex purchased. That's what I want to know. That means Alex has spent $3.95 times C. However, Alex must also add the amount spent on the card. Notice that this is going to be different because it's going to be plus. Now the Dory example, remember I subtracted $5, and the reason why I subtracted there was because that was a credit. Whereas Alex actually had to pay this money up front, so that's why we're doing a plus sign instead of a minus sign. So the equation is total cost is equal to cost of compact discs plus cost of discount card. In other words, $63.40 is equal to $3.95C plus $19.95. Now we can do the second part, solve. We use inverses, so the sign here is addition, so we're going to use subtraction. We subtract $19.95 from both sides. This becomes the number 0, which vanishes. This becomes $43.45. The operation between the $3.95 and the C is multiplication. So we do the inverse. We divide both sides by $3.95 and we get the number of CDs. We put it back into context with a sentence. If you have a word problem, you want to give your answer back in a sentence. That's putting it back into context. Alex bought 11 CDs during the year. Now we look back to see if our answer is reasonable. Check that the answer is reasonable. The cost per CD is about $4. So if Alex bought 11 CDs, this amount is about $44. Add the cost of the discount card, which is about $20, which means she spent $64 in total about. And that's close to the given amount in the problem, which is $63.40. So 11 is a very reasonable answer. Okay, I want you to try this one on your own. Pause the video. Let's read it together. Then you pause the video and you try it on your own. I want you to write and solve the equation. Ready? Sarah paid $15.95 to become a member at a gym. She then paid a monthly membership fee. Her total cost for 12 months was $735.95. How much was the monthly fee? Go ahead and pause the video now. And here's the equation. 735.95 equals 12. I've chosen F for the monthly fee, plus $15.95. If you didn't choose F or you chose another letter, totally fine. Nothing wrong with that. Total equals monthly cost plus member cost. Solving, F equals 60. Put it back into context. Sarah paid $60 per month. Last example, solving equations to find an indicated value. If 3 times A plus 12 equals 30, let's find the value of A plus 4. Sometimes you'll be asked not just to solve for a variable, but for a given expression. And A plus 4 is an expression. So step 1, let's find the value of A. Subtract 12 both sides, 3A equals 18. Divide both sides by 3, now we know that A equals 6. But that's not what we're asking. We want to know the value of the expression A plus 4. So we substitute the 6 into the A plus 4. We substitute A with the number 6. 6 plus 4 is 10. And so sometimes you'll not only be asked to solve for a variable, but you'll be asked to solve and find a value for an actual expression. Here's one I want you to try. If 2x plus 4 equals negative 24, find the value of 3 times x. Go ahead and pause the video now. Taking the equation 2x plus 4 equals negative 24 and solving it using the two-step process, I end up with x equals negative 14. Now, to find the value of 3x, I have to replace the x with negative 14. 3 times negative 14 is negative 42. So therefore, 3x, the value of 3x is negative 42. Think and discuss. Explain the steps you would follow in order to solve the equation 2x plus 1 equals 7. Explain that to somebody. How is this procedure different from the one you would follow to solve 2x minus 1 equals 7? Can you find a fellow student or maybe a parent or guardian or someone that you can talk out this with? What's the difference? What would you do to solve the first equation? What would you do to solve the second equation, and how does your answer differ between the two? And then here's something for your notebook. Get organized. Copy and complete this graphic organizer. In each box, write and solve a multiple step equation. Use addition, subtraction, multiplication, and division at least one time each. So for example, if I said 3x plus 7 is equal to 28, that would be an equation. And then you can make up your own equations, put them in there, and then solve them. And then here's the homework. God bless you, wherever you are today.